This is Self-Directed Research, where our hosts, Amos and James, give each other 20-minute presentations that usually last longer than that about whatever they've been obsessing over lately. For more episodes, show notes, and transcripts, visit sdr-podcast.com. New episodes drop every Wednesday. Today's episode is sponsored by Tweedahulf. More about them later. This week, Amos presents I Was Wrong About Rust Build Times.
All right, so my topic today is I was wrong about Rust build times. So a while ago, let's check it out. I have the article open here. In December of 2021, I published a 30-minute read. You know that's a lie. My reading time estimator is lying. But I have unit tests with some of my articles, checking that the reading time is what it should be, so I can't change it now, because then I would have to update the test. Anyway, it's about why is my Rust build so slow, and there's a bunch of headers here. What is cargo even doing? How much time are we spending on these steps? This is talking about cargo build -- timings, which I have here as this still relevant in my slides because I have slides today.
I read this blog post literally last week or 2 weeks ago when I was troubleshooting why certain builds were slow, and the answer was just a lot of generated Saturday code. So all that stuff I was talking about last time of measuring that. I read this article of going through and making sure that I had all of my line items that I wanted to check when I was digging into it.
How did you end up finding out that it was Saturday?
The way that I ended up figuring it out was I looked at the volume of generated code. So the step that I ended up doing was running cargo expand, which gives you the output of everything after expansion, and counting the line counts before and after, but also then running that expanded code through a tool called form. Basically, it takes a single file and by module splits it up into multiple files, which means if you expand, which gives you one output, and then run it through form, you end up almost with the same folder structure, which means that when you then run it through Tokay or another tool, you can do the before and after and be like, this was 2,000 lines before expansion and 54,000 lines after expansion. So I don't have a smoking bullet that it was Saturday, but Saturday and one other proc macro were generating literally 7 or 8 times the size of an already 50,000 line Rust crate.
Right. So the figures you just gave, 2,000 to 54,000, those are not exact, but it was in that ballpark, right?
For some of them, yeah. If they were just data structures in there, then it would blow up like that. If there was a lot of code, which wouldn't expand as hard, but there was a couple files we had that were just data structures that became very large generated code.
Okay, so what the heck should we do about proc macros, and can we get introspection going on again in the Rust project? Are two topics that I think will come up a bunch if we keep doing these.
Yeah.
But okay, I'm gonna go back on track on my article. I'm happy that it helped you. It did help a lot of other people as well. I know, because I got a lot of good feedback. I'm generally happy about this article. It talks about picking a better linkers. Since what has happened is that at Worldwide Developer Conference, I think that's what their acronym stands for, WWDC, the Apple Developers Conference thingy in 2022, they made their linker twice as fast, which makes it less useful to switch to a different linker. I don't have it here, but the author of Mold tried different schemes. Mold was a third-party alternative linker that was faster than all the other linkers written in C++, I believe. And the author tried a bunch of schemes to monetize it and eventually kind of gave up, I believe, and just said, okay, I guess I'm not gonna, because I think he quit his job. I should source this better.
He was the developer that actually developed LLD for LLVM and then went on to build Mold and was selling it as sold. But what came around was essentially Apple figured out what they were doing with sold, rewrote LD64 for their own thing, and then went, well, that's kind of, you just ate all of my competitive gain. I'm not going to maintain a product anymore because there's no reason for me to recommend it for anyone to buy it now that LD64 is just fast in the same way.
Yes, which is interesting because we know Apple does that with apps, right?
It's called getting Sherlocked.
The app of the year one year is going to be the next Apple app next year. So they do that. They let developers make things in their walled garden, and then they make their own version, and then you're irrelevant. But for me, I can't think of another high-profile instance of this happening in open source, I guess.
Well, they do tiling windowing now, so I guess that chewed a little bit.
Yeah.
But, yeah.
Well, I'm always surprised, ever since I went back to macOS full-time, I used to have a Windows machine, Windows 11 with Linux VMs, and now I just have Macs all around the house. It's just, there's no problem that several $1,000s cannot fix. I'm always surprised to see the thriving ecosystem of like little Mac apps that just add a
Mm.
little thing that's missing in the ecosystem. And I'm always happy to throw them like between 10 and $30 because I'm like, it's a lifetime license. It's something I need. I should make an article about all these. So Apple killed mold, and now the built-in thing is kind of okay. So RIP, but also good for everyone else. I don't know. In terms of linker as well, that slide went missing for some reason. But recently, Rusty Nightly started shipping their own, not their version of, just like they started shipping LLD and they started using it by
Mm.
default on Linux 64-bit. I don't know how much is in common between like Apple's linker is an LLVM linker. No,
I don't think it is, but I'm guessing
okay.
here. It's not the same, but it might be a fork. I don't know.
Well, someone should check it out. If only there were two dudes talking, and I'll check it out before next week. So what else in the article? The article talks about incremental builds. I get sad every time I look at this because I've talked to some people who were involved with Rusty around those features, and my understanding is that there were plans to do incremental building, but better or for more things. Like it's partially done and it works well enough locally, but definitely for CI, for example, it's not even an option because it's just so hard to know what to commit to cache. So if you're thinking of a traditional GitHub Actions CI cache workflow, you restore the cache at the beginning of the build and you save the cache at the end of the build. And the first problem you end up having is that suddenly the cache is 55 gigabytes, and that's too many gigabytes. And so you don't know what to prune, what to keep. You don't know if you can use the main branch cache for the PRs, if you should bring back the PR cache to the security concerns. What if someone poisons the cache? There's all sorts of things. And that's kind of still doable with the non-incremental builds in Rust. But with incremental builds, I don't even think anyone's trying to do it. I think a lot of tools, like if you build Rust with Nix or if you build Rust with like Bazel or Buck, or I don't know, I still need to try those and do a comparison. It's just incremental building is nice locally for your machine. Actually, there is one person or one company doing incremental builds with caches in CI, but what they did is just essentially have persistent workers. I'm assuming it's still cloud-based somewhere, but they have a bunch of workers and they just like clone them and they just bring the build to them instead of like restoring the cache somewhere else.
So like old school Jenkins, not GitHub Actions, where everything was a persistent machine and there's no isolation or VMing.
I'm assuming they're careful about it. I'm assuming it's still cloudy and like they can scale it up because it's easy to like clone a VM or like do copy on write. I don't know. There's some magic happening probably. It's the earthly people. I will add the links because I asked ChatGPT what article I was thinking of, and it found it. When you let it do web searches, it can find things. So it gave me all articles, and I was like, no, not this one, not SC Cache, none of that, and it found it was the earthly folks who did it for I forget who, but we will have the link. There's a lot of things about like Rusty self-profiling that is still accurate as far as I know. Some crates still hit pathological cases in Rusty. That's still a thing. You can get some nice gains if you know where to look. And there's cargo LLVM lines that people are using with great success. But the one thing this article says that is actually, I think, in retrospect, a very bad idea is splitting it into more crates. And I will explain both the original reasoning, why I think it's bad, and what I'm doing instead.
I was going to say, because this was my only suggestion to my client when they said, how do we make this go faster? And I go, well, we probably shouldn't have one crate that's 50,000 lines before expansion and like 200 or 300,000 lines after expansion, because you lose parallelism at that point. But I'm interested to hear why you're turned around, because before I was real ready to suggest what you suggest in this blog post, because it made sense to me.
So I ended up having too many crates is one of the things. And it's not directly related to compile times, but like development in general, having to maintain those 14 different crates, even though you have like a cargo upgrade by cargo edit, it's just a lot of, even if you inherit dependency versions from the workspace, even if you inherit the crate version from the workspace, which are all things you can do. I don't know. I had to think about a lot of things all the time. It was a barrier to just developing the thing. So that's one thing. I think where my calculation went wrong, and I want to actually go and back it with hard data, which I don't have today, but I have in the future for an actual write-up, is that, sure, the crates can compile in parallel, but define compile, right? They can be parsed in parallel. That was already a thing. I don't know if Cargo Rusty actually does it, but it could, right? I'm sure there's opportunities for parsing things in parallel. I haven't checked, but
There's the parallel front ends feature, and then I can't remember all the stages that are real or nightly only today.
right. Yeah, if you run cargo build dash timings, you can see your different crates actually building in parallel. But it ends up doing more work because since you're now using things across crates, you have to declare a bunch of things pub. So whereas previously you could do like intra-crate, so inside the same crate, it could do inlining, it could do a lot of things because it has all the code. It doesn't even need to like export those symbols. They're not in the object files, they're in the archive files. The linker doesn't have to know about them. Rusty can just do its little cooking on the side and then generate only what LLVM needs to know about. Now there's a bunch of things that are pub. And so it's all exported, it's all in file, and the linker now has to worry about all of that, which would be fine because, as we just said, linkers got faster. But the other thing is now we have link time optimization, which I really want to measure because I feel like it's taking so long. Even if you have like the fast linker on Earth that does all the optimizations that Mold did and still does, you still have this thing where like linkers will call a plugin to figure out what optimizations can they do across different compilation units. And that takes a lot of time. And if you're splitting all your crates in different crates, it has to do this every time because you have one binary that depends on all your workspace. And every time you change any of these, it has to link again. So if it was like one crate and you have incremental caching, then it can cache actually some of that. But I don't think the result of LTO is cached anywhere.
Well, I think thin LTO does. So I think this is the difference between thin LTO and fat LTO. So fat LTO, my working model for it is it takes all the compilation artifacts, vomits them as if they were one giant object file, and then runs optimization on them again without having this separate. Whereas thin LTO keeps the LVM like bit code for each of the stages and can't do quite as powerful optimizations, but it doesn't have to, like you said, revomit everything into one pile so that it can optimize it again. It can do this all by parts, but it does lose some optimization opportunities there.
Sure. But again, I wish I had numbers to back it up, but
Sure.
my experience, it still spends time there. It is, for sure, fat LTO, which is non-thin LTO, whatever, regular LTO, classic LTO, definitely takes more time than thin LTO. Also, I think the default for dev build is something called thin local LTO or something, like crate local. This is like another level.
The LTO flag in Cargo Toml is one of the worst ones because it has a value, like you can put a string or a boolean there, and if you put false, it does thin LTO, and if you do true, it does full LTO.
So false does thin local LTO, the thing I was just talking about. True or fat is the same thing.
It trips people up all the time, and it's one of those I always have to go and look at it because I'm like, it makes sense historically why it's like that, but it makes me so upset because we don't usually deal with truthiness in Rust, and this is one of the few times we have to, and it confuses everyone when I see it.
This is worse than YAML, because it's false and off are different values here. At least in YAML is consistent,
And also Norway.
I think in retrospect, it was bad advice. It didn't end up helping much for me. I think the numbers are like wishy-washy. I wasn't very scientific about it.
The other thing you haven't mentioned is the orphan rule. This is the other one that I see people complain about a lot when they have broken things up into many crates is, like you said, the other maintenance things of having to span multiple crates. The orphan rule is a big one where you want to be able to impl your trait for a lot of things, and that becomes way harder when you go from modules to crates. So do you have something that you would recommend today, or is this where this is like proposal for more research of I need to figure out which...
So the slides end here, but my thoughts don't.
Okay.
It's not just I was wrong, and I think it was a bad idea. I do have a plan that I'm currently enacting in my proprietary code base. I don't know how much proprietary code I have, but actually it's pretty easy to find out now because I just brought everything together. That sounds wrong. I don't have 1,800,000 lines of code. Where does that come from? I have about 18,000 lines of Rust because my website does a lot of things. It has this whole asset pipeline. It encodes images to like Avif and WebP and whatnot. I have a whole video pipeline as well because I have a clone of the YouTube player on my website for patrons so you don't have to sit through ads. I have the markdown pipeline. I have KTech for equations. I have a lot of dependency. I think it's about 1,000 crates. And it used to be separated into a bunch of different code bases. And one of the code bases, the blog, used to be separated into a bunch of crates because of that article. So what I've spent the last couple days doing is actually put everything back into one single crate. And then the rest of the plan is to isolate things by how long it takes to build and make those into dynamic libraries, which in most other languages, well, no, in C or C++ would be okay, I guess, because that's what people have been doing forever. And it's kind of how Linux distributions work. You just install dynamic libraries somewhere, and then everything like shares the same version of things. But in Rust specifically is complicated because we don't have a stable ABI for a good reason, but still. The compiler kind of doesn't want you to do that. It's not just the switch from like, oh, this crate should be dynamic, just do that. I think it's not that easy. Or maybe it is, but like then you have to make sure that the compiler version used is the exact same, so you run into this kind of issues.
You already have like extern Rust unsafe stuff, which you can do.
Well,
Yeah.
actually, tell because I just skipped over it, like knowing it's a headache, but maybe you know the details of the headache, so please tell me.
I was going to say, if you manually, I solemnly swear that I'm only using one version of the compiler with it, then you can extern and like consume extern definitions and have them be linked in. Like I said, I do a lot of embedded, so we haven't done a lot of dynamic linking because most microcontrollers don't have dynamic linkers.
I guess so.
But I know that's how the compiler generally works with things like compile derive macros and things like that. Those are essentially compiler plugins, and we can do the same thing, but it ends up being very easy to footgun. But if you promise that you're always doing a clean build of the entire system so that you can do a deployment, then that's not necessarily very unreasonable. It's just not very portable to give to someone else.
I was fact checking you in real time. Here's the funny thing that happened. So I looked at extern Rust because I forgot that was a thing, but then remembered as you brought it up. So I looked at the Rust reference, but then I looked at the proc macro bridge because you explained that's how it works, just does extern Rust. And the first result is, of course, an article by me about proc macro support in Rustlizer. I forgot. They do a weird, interesting thing, which might be worth discussing another time. If you can guarantee that you're using the same version of everything everywhere, then that's fine. But I don't want to have that constraint. So one crate that lets you have a stable ABI, no matter what the Rusty version is stabby. Stabby ABI is the ABI crate itself, but stabby is the thing with like proc macros. And the README does a good job at explaining what it does. But yeah, essentially, instead of making everything a rep C, which is what you would do if you wouldn't want a stable API most of the time, or if you have to interface with C and C++, you use this, and then you can have this sort of plugin system where you have some traits, and they are implemented by shared objects that you can load at runtime. And for me, for this code base specifically, this makes sense for me because I'm not actually going to load and unload them. Unloading them is the thing that you really should never do with Rust. I also have an article about loading and unloading things for like, I forget what it's called. You're iterating on some things, you're just recompiling bits of it. They do that with Bevy for game development. For this project, my blog, I just need to load all the plugins at runtime. And I think I can get a lot of gains here because, for example, KTech pulls in an entire JavaScript engine. So if I only have to build that once, that's good. I don't know, all of SQLite. I can put SQLite into its own dynamic thing and it's fine. And so, of course, you lose out on like, there's no LTO going on anymore because it's actually dynamic. It's too late to inline. There's no JITs there to save you. For like clear interfaces, I don't know, S3 storage pulls in a bunch of crates. It's all async. Async interfaces do work with Stabby. Just put them in a shared object and see what happens. So this is my new approach. I haven't finished it yet. I will keep you posted. But I just wanted to say that actually breaking things down into crates is not enough because you'll get caught at LTO time. It slows down development in general. And also, I did it too much. I don't think it helped much because, especially in a workspace, maybe that's the last thing I want to cover on this, is that unless you use Cargo Hakari, I don't know if you've used it before, which does the workspace hack.
Yeah. Wait, can you explain the workspace hack? Because I have a customer using it and I don't totally wrap my head around it because someone else at the customer set it up, but it broke some stuff and then the stuff got fixed. What is the workspace hack and how does Hikari help you with the workspace hack?
There's a chance the explanation I will give is completely wrong because I want to do it off the top of my head. I can tell you the problem it's supposed to solve. If in a workspace you have different members that depend on the same dependencies, say you have like 3 different crates in your workspace, they all depend on cert A, but they have slightly different feature flags, then they don't actually share the artifacts. Like you're going to have 3 different builds of Serde for this workspace. And the workspace hack is just, okay, let's have a single crate that has all the dependencies that anything in your workspace depends on. And then
Force unification on all of it. Yeah.
yes,
Okay.
it's going to have all the features you want enabled, like the union of all features that all the others are using. And then there's a crate, cargo subcommand called cargo hakari. I don't know how to pronounce it. That sets it up for you and updates it for you. And it's really nice. And I've used it in the past. But yeah, if you don't do that, if you forget to do that, then you might think that, yeah, okay, I had this big dependency tree, I put it in a different crate and I don't touch it. So every time it's going to be cached. Actually, no, the rewards is not as good as I thought it was.
I'm interested in this because I want to see someone do dynamic loading because I haven't seen many people mess with that. So I'm excited because I know when you write it up, it will be written up. The other thing, though, is I want to poke you to have a more realistic baseline that if you are saying, hey, I'm not going to get LTO because I am isolating all of these components, make that your baseline. Like change your cargo profile so that you have LTO completely turned off. You have maximum code gen units. You have maybe even nightly like parallel front end and things like that of, okay, well, if you really are saying that you're willing to give these things up because you're going to have dynamic plugins, what happens if you go all the way back? Because I've seen some A's and B's before we go, this is the worst that this can get with full LTO and everything like that. And then you compare it with the leanest possible setup ever where you've made all of these compromises. And I'm not saying you specifically, but this is that, I think we talked about this before, the perils of benchmark of like, I've implemented 10% of the problem and hey, look, it's 10 times faster kind of hint. But I'd be interested to hear, especially if you have realistic perf numbers of how much slower is it without LTO or how much slower is it with dynamic linking if you have any sort of like perf numbers to play with, because not just how fast it compiles, what are you losing for that trade-off?
Yeah, for sure. Yeah, if I do a write-up about this or a video, I haven't decided yet. It will be either of these because I think it's a very interesting topic. I will definitely, start from like, if you don't have any dynamic loading, you like full static linking, like fat LTO, all the things, like you said, code gen units to 1, I think. Is that it? Yeah.
Well, 1 would make it more optimized, but slower.
Yeah. So we go from like the most optimizations with the slowest build to like the other end of the spectrum without changing the linking style, and then to dynamic linking. But one thing I'm specifically excited about with dynamic linking is that even if like, because the C dependencies I've talked about get recompiled, like SQLite, like the JavaScript engine, those get rebuilt, I don't know, when I upgrade to a new major Rust version or like I cargo clean accidentally or something. But most of the time when you just run cargo check, which happens when you save the file in the text editor, they don't actually get rebuilt. But cargo check is still slow. It's still freaking slow because there's like so many crates in the depth tree. One thing that didn't go all the way, was talking about incremental compilation, is that I really wish we just had a compiler server instead of a compiler CLI, because you can design the cache file format the best you can. It still has all this work to do. Like it wakes up, it's like, okay, do we have a Rust toolchain file around here? Okay, we found the right Rusty, let's boot it up. Okay. And then it has like, oh boy, we have a lot of cache files on this, better read all those. And even if it's like, obviously it's going to be memory cache, the operating system, it's not actually going to read from disk. That's still a lot of work to then realize, oh, well, darn it, everything's up to date. We don't have anything to do here. And it just shuts down. Sure, it's not Node.js, it's not Ruby. It does that in like a couple 100 milliseconds maybe. But it's still work that a server could just say, yeah, I know it's up to date, nothing changed. Instantly.
If you haven't read Alexei or matklad's writings on different approaches for different compilers, he makes sort of an A and B explanation of at least Rust Analyzer versus Rust C, where Rust C is a batch compiler, where Rust Analyzer is sort of a live incremental compiler. There's one post that he has that's a really good proposal that's like, hey, if you're designing a new language now, start with an incremental server first rather than a batch compiler, because most users end up wanting those features. Basically, he makes a proposal that says everyone starts with a batch compiler because it's easy and then generally works towards an incremental compiler, and no one started with an incremental compiler first, unless, well, I've talked to some folks about like Smalltalk, more dynamic environments where it's meant to be sort of a live system that you are playing with and introspecting and poking, where you have a more interactive view of your compiler. So if you haven't read those articles, you should. And if anyone's interested in what exactly you are talking about right now, they should go look at matklad's blog, which is also tremendous.
That is true. However, I should mention that I have read, I think, everything matklad has written on the topic, and I think everyone listening to this should read about them. I also know that Alex has experimented with other languages. I don't know if it's even active in Rust nowadays anymore. There was a point where I was thinking, oh, cool, Rustlinizers the future is going to take over Rusty because it's incremental. It's already re-implemented a lot of the same stuff. So like I was thinking of a future with like Rustlizer, Polonius for board checking, the new trait engine, Chalk, I think. But then all those illusions have kind of been removed from me because Polonius turns out may not be the right way to go. Maybe there's another way to do all of this. Chalk, I think, is being abandoned in favor of rewriting it another time. And Rustlizer will never replace Rusty for a lot of reasons. And does not even support all the things Rusty supports. And I think we've already added things to the language that makes it impractical to have that approach. So Rustlizer does like the best it can, but it can never actually replace this. But I do believe that if you gave someone a bit of money, which is giving them a bit of time, they could like hack it and just have the server, and instead of reading everything from disk all the time, just like have the interface be parsing cargo args, whatever, but then keeping things in memory instead of reading them from disk all the time. Because I know the Rust compiler does cache things in memory, right? It has this query system by something like Salsa, which Rustlizer also has. And if you query the same thing a bunch of times, which happens a lot during compilation, it doesn't actually recompute all the things. It does memoization heavily. So just keep that in memory, right? How hard can it be?
I think the people that complain about how much memory Rust Analyzer use can talk exactly about how hard that is. But I'm interested to see more people hacking on it, like 100%.
Me too.
This episode is sponsored by Tweedehalf. Tweedehalf is a Rust consultancy from the Netherlands that you may know from their open source work like NTPD-RS and Staytime, or from their work organizing RustNL, the Dutch yearly Rust conference. I've worked with them for a couple of years, and I would personally recommend reaching out to them if you need help building software in Rust, embedded or otherwise, or to book a training to get your teams up to speed on topics like using async on bare metal systems. Links to contact them are available in our show notes, and don't forget to let them know we sent you. Thank you again to Tweedehalf for sponsoring this episode.
This episode was edited and produced by Amanda Miarovich. The logo was created by Bread, and Jamie Dixon produced the music. Check out their contact info on sdr-podcast.com.